probability. That's what we're talking about today. Whoops, let me get that box out of the way. And geometric probability is almost just like it sounds. It's probability that involves some kind of geometry. Okay, I'm going to be a little bit more specific when I write this down, but it's probability that involves some sort of geometric measure. Such as length or area. Okay? Probability that involves some sort of geometric measure, like length and area are the big two that you're going to be using quite a bit. Oh, sorry. Probably making you all dizzy. And the other thing I want to remind you about probability, this you've probably already learned before, but the basic premise of probability is that it's a ratio or fraction that compares what you want, so the desired outcomes, to all the possible outcomes. Okay, that's going to be important to keep in mind. So let's look at number 1. It says point X is chosen at random on AD. So I'm closing my eyes and just kind of randomly picking a point somewhere on AD. Find the probability that X will land on BC. So first thing I would do is say, what's the total amount of space that that point could land on? What am I going to do for that? Bryce, what were you going to say? Okay, but I wasn't listening to them. Okay, nope. The total places that that point could land. Okay, 14, because if I add up the entire length, the total distance that that point could land on is 14. Now, out of that 14, how much of that is where I want it to be on BC? That would be 7, right? So it could land on 7 units out of the total 14 units, which is 1/2, yep? Or I would take it as a decimal. Okay? A Chicago Transit Authority train arrives or departs at a station every 15 minutes on the red line. Assuming you arrive at a random time, what is the probability you'll have to wait 5 or more minutes for a train? So here's what I would do with this one. I would say this is when one train leaves. Okay, it's over here, Travis. It's one on the end here. And down here is when the next train arrives. So that's 15 minutes in between, right? Okay. So my total possible places that I could end up at the station is somewhere between 0 and 15, because every 15 minutes it resets and another train shows up. Does that make sense? That every 15 minutes I'm kind of starting over? So I want to know what is out of those 15 minutes, so my probability is going to be something out of 15. What is the probability you'll have to wait 5 or more minutes? Okay, well, how many minutes are there in there where you would be waiting 5 or more minutes, Bryce? 10 of those minutes, right? I'm going to kind of split this up in 5s. Okay, so if I arrive in here, I'm only going to wait 5 minutes or less. But all of this, I'm going to be waiting more than 5 minutes, right? Because there's a train arriving here, there's a train arriving here. So this would be 10 out of 15, which reduces to 2/3. Okay? Nick? Yeah, part over whole works too, as long as you remember the part is the part you want, and the whole is all of the possibilities. Yeah. Okay, suppose a skydiver must land on a target of 3 concentric circles. Anyone remember what concentric means?
It's like a cone.
Good guess, but not quite. What else do you see in here?
Centric.
Centric, like center.
Oh, it's got one of those
Right. It's 3 circles that have the same center. So it's like a bullseye. It's like a target. Okay? So here's what you've got. You've got like one circle, and then you've got another circle around it, and then you've got another circle around that. 3 concentric circles. Okay? The diameter of the center circle is 2 yards. So this diameter, make sure you read that carefully, is 2. And then the circles are spaced 1 yard apart. So this is 1 and this is 1. Okay. Right. Yep. So this would be a diameter of 4, and then this would be a diameter of 6 on the outside. What is the probability that the skydiver will land in the center circle? Okay. Bryce, what are we going to do?
Would you just do the 2 over 12?
Not quite that easy. Kyle? I'm sorry, I can't hear you. Nope, not quite that easy either.
You find like the area of the whole circle and then subtract the area of the
Yeah, not really subtract, but
put it over there.
yeah. We're gonna have to use areas here. So it's not just about the diameter, it's about that whole space, because they can land anywhere in this circle, right? So I would do the area of the center circle and divide it by the area of the outer circle. And I'm going to do this with exact values, meaning I'm not going to use 3.14 for pi, because that's going to make my life easy in just a second. So how would I set up area of the center circle? Careful, how do you do area of a circle? Nope. Okay, it's pi r squared. The radius of this circle is 1. So the center circle is pi times 1 squared.
So just do pi.
Yep. And the area of the outer circle, the radius here would be 1, 1, and 1. So that would be a radius of 3. Everyone see where I'm getting the radius of 3 from? I'll outline it for you if you don't see it. If I'm looking at this outer circle here, starting at the center, this is 1 yard, and then another yard, and another yard. So that's 3 yards total. Now look at that fraction. What's going to happen with your pi's? They cross off. And so you really end up with 1 squared, which is 1, over 3 squared, which is 9. That's your probability. Okay? So you've got to be careful when you're working with areas that you're finding the whole area and not using just the measurements. Okay, just the dimensions. Making sense? Good. One more example. Okay, we're going to find the probability that we land in each section. So the probability that we land in yellow is this wedge here. And we know that the yellow is 45 degrees out of how many? Yeah, so my probability of landing in yellow is 45 of the degrees out of 360 of the degrees. Okay. We could mess around with finding like sector area and stuff like that, but it's all going to be proportional. So I can just do the degrees. And let's see, 45 out of 360 I think reduces to 1/8. If I can be right. Yeah, that's right. Okay, purple is this one up here. So how am I going to set that one up? 105 out of 360, yep. And that's going to be 21 out of 72. Actually, that can be reduced further. That's going to be 7 out of 3 into 72 is 24. I think 7 out of 24. Is that what you said? Yeah. I'm sorry, I thought you said 7 point something. Oh, Adam said that? Sorry. My mental math was going. Okay, look at the next question. I don't want to land, or lad. I didn't type this. I don't want to land on red or blue. So I don't want to land here, and I don't want to land here. What are you going to do with that?
240.
Where'd you get 240 from?
Because I said 120 from 50.
Okay.
I didn't.
Robin, why don't you give it a try? You had something to say, right?
Yeah.
Okay, so yeah, you could add all three of these up, right? Or you could add these two up and subtract from 360, and that would give you what was left. Either way, you're right, you're going to come out with 240. Because this is 120, this is 240. So you're right, I would look at the ones that you do want, add those up, and that's 240 out of 360. Which should come out to be 2/3. Okay, if you divide that. Think you can handle a few of these today?
That's pretty.
Awesome. That's what I like to hear.